you're going to find the HCF. It's division algorithm. I told you that we can, what was the lemma? We have two numbers A and B. These numbers can always be written as A is equal to B times of Q plus R. So let's try to write it. Which one will be our A and which one will be B over here? Which is A and B? Tell me.
A is 12,570.
Yes, the bigger number we will take it as A and the smaller number will be 4052. Now I have to write this A in such a way that 12576 should be B times of 4052 into some number plus the remainder. How can we find it? We have to do the division. So do the division and tell me what is the quotient and remainder here, guys. Everyone knows how to do division, right?
Sir, quotient is 3 and remainder is 426.
What is that? Tell me what is the quotient?
3, sir.
Yes. So it's 4,000 and this is 12,000. So we should try with 3 times. So it will be 3 2s are 6. 8. That. Right? So 4052 will multiply 3 times so that we get a remainder of 120. Okay. As you can see here, 4053 plus 420. Now, what we are expecting is we have to keep doing this thing until the remainder becomes 0. So since here the remainder was not 0, we need to follow the next step. Now what is that? Again, we have to apply the same logic, but this time A and B will change. What do I have to consider as my A? Is the divisor itself. What was the divisor in the previous step? That becomes the new dividend now. Okay, so 4052.
Sir, here why are we taking that 12576 as the A, sir?
Because according to the Euclids division lemma, the bigger number we have to consider as A, and that bigger number A can be represented in the form of A is equal to BQ plus R, where Q is the quotient and R is the remainder. So of course, dividend has to be bigger than the divisor, no?
Yes, sir. Okay, sir.
Okay. So the dividend is bigger than the divisor. So that's why we took this one as A and this one as B in the first step. Now, like I said, this was step 1. We are going to the step 2. Again, we have to do the same thing. We have to write it in the same form. A is equal to BQ plus R, but with a minor change. What is that? The divisor becomes the dividend now. Remember that. Divisor becomes the dividend. Then what should be my divisor this time? You see,
420, sir.
whichever was the remainder in the previous step, that becomes your divisor. This 420 becomes the divisor now. Now 420 into what? Can we find out the quotient and remainder for this one? This time you'll have to do the division. 420 and 4052. See guys, this is an algorithm. Okay, algorithm means it's a set of instructions which you need to follow to achieve some result. So don't ask me why this is happening. Why are we doing this? Because this is a complex algorithm, and to explain why this works is fairly complicated. Okay, and that's not part of your syllabus. You don't need to worry how the algorithm works. All you need to learn is how to use this algorithm, which is Euclid's division algorithm. And if you use this Euclid's division algorithm, you will be able to find the HCF of two numbers like this, A and B. All you need to do is remember how to follow the steps. In first step, A and B were given already, so you did this representation. In step 2, divisor becomes the dividend and the remainder becomes the divisor. So tell me if anyone has found out. What is the remainder?
9.
So this is 4 and this is 40. So 9 times you can try, of course, yes. So it's 0, 2 are 18, 36 and 37. So what is the remainder?
272, sir.
So still the remainder is not 0, but we have got our quotient and remainder. So let's write it down. Quotient is 9 and the remainder is 72. Again, what will happen now? Since the remainder is still not 0, we will follow the same step again. This time, what will be my A value here? Tell me which one should I take as the dividend?
420, sir.
Yes, it's the whatever is the divisor that becomes the new dividend. So it will be 420. And what will be my divisor?
272.
The remainder becomes the divisor. So it will be 272. Do the division again. This time you'll have to do a division of 272 and 420.
Sir, quotient is 1 and remainder is 148.
Okay. So it become 72 times of 1 plus 148. Still the remainder is not 0, so we'll have to do the same thing again. What's my dividend this time?
$272.
Whatever was the divisor, that becomes the new dividend. So 272 is equal to 148 times of what?
Into 1, sir.
Yes, of course, 148 will not go more than one time. So do that and tell me what's the remainder.
124.
Yes. So again, it has gone only one time plus 124. Still the remainder is not 0. Continue doing the same step again. So this time, what's my dividend? Previous divisor, right? 148.
Yes, sir.
The remainder is the new, tell me, 124. Again, only one time.
22.
24, sir.
Still not 0. Continue doing the same thing. Now this time it's 124. This is 24 into what?
5, sir.
5 times. How much is that?
Remainder 4, sir.
So 24.
Sir, after getting the remainder 0, what should we do, sir?
Yes, you will see that. Have patience. So we have got this. Still remainder is not 0. Continue doing the same thing again. This time it's 24 here is equal to 4 times of what? So of course we know that 4 6 is 24 and remainder will become 0. So this is what we wanted. The remainder to become 0. We have got the remainder 0. So when this happens, when you get the remainder is equal to 0, then you can say that whatever is the divisor at the stage is, that becomes the HCF of the two numbers. So which is 4. 4 is the highest common factor of these two numbers. So the steps are fairly easy, right? Everyone understood what steps you need to follow?
Yes, sir.
So anyway, you'll practice more sums and then you'll remember it. Don't worry, don't try to think that this may seem a little complicated to people who have not done this already. So it's all right. HCF of 1, 2, what was the number? 576. 405. Is 4. Just kept on applying the Euclids division lemma again and again by choosing different a and b values. Every time, what did we do? Until the remainder becomes 0, whatever is the divisor, that becomes the new dividend, and whatever is the remainder, that becomes the new divisor. And once you get the remainder as 0, then whatever is the divisor at that stage, that becomes your HCF. Okay. Fine. So speak up. Exercise 1.1 and use the Euclid's division algorithm to find the HCF of these two numbers. Do this very quickly, guys. I will also do this question for you people. If you you need help, you can look at me. Otherwise, if you have already understood, try to do this on your own. Guys, anyone needs help with this? Do you want me to explain this?
Sir, completed, sir.
Let's wait for some time, British. For the people, anyone needs help with this? Do you want me to explain this one more time?
Completed, sir.
Anushri, Vidula,
Completed, sir.
Completed.
okay. Tell me, what is the HCF did you get?
2.
45, sir.
Yes, the divisor, not the quotient. You see, when you do 45, 45 was the remainder in the previous step, no? So 45 became the new divisor. So 45 is your HCF, not the 2, okay? Be very clear about that.
Sir, one also we can take no, sir.
Please tell me, again, I couldn't understand.
Sir, we can take one also, no, sir. HCF.
1 is a common factor for every number. We are trying to find the highest common factor, right? Not the lowest common factor.
Yes, sir. Okay, sir.
So 1 will always be a factor of everything, but you need to look for the highest number, which is the common factor. In this case, it is 45. on guys for a minute. Okay. So yeah, continue doing the other sums. Second, third. So solve this with me, guys. Tell me. 8220.
Completed, sir.
Okay, good. So tell me what should the quotient be here?
195, sir. 195.
And what's the remainder?
0, sir.
Okay. In the first step itself, we got the remainder 0 here. So what is the HCF then?
196.
196.
Yes. Whatever is the divisor at that stage, that will be your HCF. Okay. Remember, B is the one which we had taken as the divisor, and A is your dividend. So it has to be 196. Don't confuse with 195. Is everyone okay with this? Confirm, guys, everyone? Everyone had got this one? 196 is the answer. So it's common sense, right? 196.
Yes, sir.
This is directly divisible, so 196 will be the HCF of the. Okay, let's do the last this one.
Completed, sir.
Okay, good. Tell me, Ritesh, what is the quotient here?
3, sir.
So 255 3 times into 867. So what do we get? Is that right?
Yes, sir. Be my new dividend. 255.
And what's my divisor?
102.
Someone else who has done it, tell me what will be the quotient and remainder here now.
51.
So 102, we are dividing 255. How many times?
2, sir.
Is that right? 2 times, and the remainder is 51. Is that correct?
Yes, sir.
Yes, sir.
Okay. So what's my new dividend now? Tanushri will tell me. What should be my new dividend? The previous divisor.
102.
Yes. Yes, that's good. And what's the new divisor now? Vidula? Are you there?
Sir, shall I tell, sir?
Yes, sir.
Yes, Midula. You're able to follow? What should be my new divisor now? The remainder in the previous step becomes the new divisor. So it was 51 was the remainder, no? You see? Are you getting it?
Yes, sir. Yes, sir.
So do the division, divide 102 by 51 this time.
Yes, sir.
It will go 2 times, of course, and it will become 102, and the remainder will be 0. So since we got the remainder as 0, this will become the, this is where we stop. So what is my HCF this time?
51.
Yes, HCF is the divisor at this stage. It's the divisor.
Yes.
So if you people are confusing, some of you are confusing with the dividend, divisor, quotient, remainder. So I will write that for you. But remember, you don't have to write this thing. This is just for you. I'm writing. You don't have to write this down. So this is just for your understanding. You don't have to write that. So I hope everyone has understood how to use Euclid's division algorithm to find the HCF of two numbers. This is a very important question. You have to remember it. If this is there in the syllabus, you might have to practice this and get comfortable with this. So I'll share some additional questions that you can practice later. Okay, I will share. So that's it for the maths class today, guys. Anyone has any doubt? Whatever we have discussed today? No? Okay, then that's it for the maths class.